All right, y'all, today's going to be a relatively quick day. We're going to move on to some of the formulas that are lower on your note card. Specifically, we're going to work with the sum and difference of angles formulas. Okay, there are 4 of them. 2 of them represent cosine of a value, and 2 of them represent sine of a value. You'll notice there's a positive and a negative for the sum and the difference of each of these. These formulas are going to be used when we're asked to find the exact value of a trig expression, and we can't draw a triangle or use one of the original points on the unit circle. So 75 degrees is not one of our nice triangles, so instead what we're going to do is expand it using our nice values. So our first step is to rewrite this. And what I'm going to have you do to kind of save some effort here is we are going to always kind of go in the same order. So if we see an expression or an angle that ends in 5, I want you to start with 45 degrees because we know a 45-degree triangle is something we can find the cosine of. And then we just have to figure out whatever's left to get to that second value, and that would be 30 degrees. So now this looks very much like this first one, where these variables are just alpha and beta. Think of them as the first angle and the second angle. Okay, so you can put that here to kind of help you as you fill this in. So our formula says that we can find the exact value of this by taking the cosine of the first angle times the cosine of the second. So that's cosine 45 times cosine 30. And then we're going to subtract sine of both angles. So sine 45 times sine 30. And on a 45 triangle, both the sine and the cosine are the square root of 1, or 1 over square root of 2, which we call square root of 2 over 2. So I can plug that part in right now. And now we just have to find on a 30-degree triangle what is happening. So on a 30-degree triangle, we've got 1, 2, square root of 3. If we're looking at cosine, we've got square root of 3 over 2. And then over here, sine of that opposite over hypotenuse is 1/2. And then we just pay attention to order of operations. We have to multiply before we can subtract. So straight across, we're allowed to multiply those square root of 6 over 4. And then over here, square root of 2 over 4. And you can write it like this, or you can group that together since we have a common denominator. We can't subtract the 6 and the 2 since they're under different square root symbols, but we can smush them into one fraction. So we're saying that the cosine of 75 degrees is equivalent to the square root of 6 minus the square root of 2, all divided by 4. Okay. And what I'm going to do to kind of convince you of that is just have you check this with your calculator. Anything that we have a value to plug in, we can check. So if you type in cosine 75, we're going to get an ugly decimal. I know that because this is irrational. Okay, I'm going to check my mode. We are in degrees. That's good. And we're just checking that this expression is equivalent. So square root of 6 minus square root of 2. You'll notice I put parentheses around that. You need to do that or just hit enter before dividing by 4. And those match up. Okay. That is it for this first one. And we're going to move on to another one. Same thing goes. We're dealing with the parent function of sine, but we're going to split this up since it's not a perfect triangle we know into angles that we do know, 45 degrees, and whatever we need to add to get to 105. So in this case, we would need to add 60. And both of those are nice triangles that we know. So we're looking this time at this formula to go with sine. So we've got sine of the first angle, which is 45, times cosine of the second angle. So that's cosine of 60. And again, if it helps, write your alpha and your beta. Then plus cosine of the 45 times the sine of the 60. Okay, we just talked about with 45 triangles, we're going to have the square root of 2 over 2. So we'll go ahead and fill those in. And now we're focusing on a 60-degree triangle. Okay, so what I'm going to talk about here, in general, we know that a 60-30 triangle is going to have the numbers 1/2 and the square root of 3 over 2. The only part that you can really mess up here is watching out for signs. Right now, I've only seen angles in quadrant 1, so I really don't have to worry about positive or negative. But in general, if you're worried about messing this up, I want you to go back to your calculator again, because we know the answers that are going to show up are 1/2 or the square root of 2 over 2, or excuse me, square root of 3 over 2. So if I type in cosine of 60, I know that is 1/2, because I know 0.5. And then the other one has to be the square root of 3 over 2, but again, sign, positive or negative, might be an issue. That's our decimal. That means the square root of 3 over 2, and it'll tell you whether it's positive or negative. So that's something you can use if you're worried about messing up with those other angles that aren't as obvious. Okay, so for this one, we've got square root of 2 over 4 straight across, plus, again, square root of 6 over 4. You're going to see a lot of the same types of fractions show up, just like we do with our special triangles. So we are saying that the sine of 105 degrees is equivalent to the square root of 2 plus the square root of 6 all over 4. And again, you want to check this because you can. So sine of 105, we want to make sure that that is the same as this fraction. I'll show you without parentheses this time. You just have to make sure that before you divide, you hit enter, and they match up. Notice on this one we have a negative. We're still going to treat it the same way. Okay, we want to start, if this ends in 5, just with a 45. So cosine 45. And if we want to get to a negative number, the easiest way to do that is subtract a value. Okay, you do have to be a little bit careful here when you're thinking about negatives. We have to subtract getting rid of that 45 and going 75 past it. Really, that means take 75 plus 45, and that's 120. You can always check yourself by literally typing that in and making sure it's equal to the negative 75, but just always know that these two have to be equivalent statements. We're just substituting there. Okay, which means we are using this formula. Our alpha is 45. Our beta is 120. It's not negative 120. It's just 120. This formula takes care of that sign change for us. Okay, so make sure you're using the right one, and we won't ever use negative angles as we sub in here. So we've got cosine 45 times cosine 120, and then plus sine 45 times sine 120. So here we know square root of 2 over 2. What I was talking about, we know we're looking at 120, an angle like that is going to be in quadrant 2. So cosine is negative going to the left. But again, if you're worried about messing up the sign, you can type that in, and that's going to be a negative 1/2 it'll show you. Okay, here, square root of 2 over 2. Sine in quadrant 2 is positive, and it has to be the other fraction, so it has to be square root of 3 over 2. But going back in, you can always check it with your calculator, square root of 3 over 2, as long as you know that decimal. Simplifying, a negative and a positive makes a negative square root of 2 over 4. And then this one is positive 6 underneath that square root over 4. So cosine of a negative 75 degrees, we're saying, is square root of 6 minus the square root of 2, just moving that negative to the end. Doesn't matter if you rearrange it or not for me, as long as you're careful. And we're going to type that in to check it. Now think about this with me, about overall sign of this, because it is possible for this answer to be negative. If we go clockwise 75 degrees, we are in quadrant 4. So we should have still a positive answer with cosine. Let's check that. Positive decimal, that's good. And then we just type in our value to check it. And there it is. Okay, 195, same type of problem. 45 plus, And then we need to get to 195, so that's 150. A 150 is a nice triangle, but now I am down here. Sine 45 times cosine 150 plus cosine 45 times sine 150. Okay. Same idea as last time, square root of 2 over 2 is a given. Cosine of 150, again we're in the second quadrant, should be a negative number. And this one's reversed from last time, so it's the square root of 3 over 2. But again, you can type this in. I encourage you to just for time purposes so you can see that. Same thing over here. Sine of 150 is positive in quadrant 2. And then 150 is going to have a sine ratio of 1/2 the other one. So I've got a negative square root of 6 over 4 and a positive square root of 2 over 4 for a final answer of sine 195 degrees equal to the square root of 2 minus the square root of 6 all over 4. Remember to type that in to check it. All right, looking at these ones, sine of negative 165. See a sign with a negative here. Again, we're starting with 45 degrees, but we're going to have to subtract to get to a negative. Okay, remember here, in order to get to a negative, I have to get rid of that whole 45 and go 165 past it. So we're really adding those two numbers together. So that's really 210. Okay, so you can subtract those to see, but you're adding the difference when we've got negatives going on. Okay, so this one is our last formula. The one we haven't seen yet is subtraction with sign, and we're just plugging in like we have been. Sine 45 times cosine 210. Remember, even though this is negative, our formula is taking care of whether it's adding or subtracting, so you do not want to have negative angles. Okay, so just cosine 210 minus cosine of the first angle times sine of the second. Sine of 45 is square root of 2 over 2. Cosine of 210. Now we are in quadrant 3. But remember, if you forget that, you can just type this in, cosine 210. It's going to show you it's negative, and it's that negative square root of 3 over 2. Okay. Minus square root of 2 over 2. Sine of 210 is also negative, and it's the other fraction 1/2. Type it in if you need to. Here we've got a negative square root of 6 over 4. On this side, watch out for your double negatives. We're going to have a plus the square root of 2 over 4 for a final answer of sine of negative 165 degrees, being the square root of 2 minus the square root of 6 all over 4. Okay, this is a negative ratio because when we're going clockwise 165, we end up over here. And you'll notice the square root of 6 was bigger. That will end up with a negative result. Always type it in to check. Now, you'll notice number 6 is a little bit different. It is the only answer so far that has ended in the number 0. Y'all, let me tell you something. If your angle ends in the number 0, you can still use this formula, but you shouldn't have to. Okay? What I mean by that is if it ends in 0, what we're going to find out is that this is something that can be drawn out as a triangle. This says clockwise 210 degrees. Here's clockwise 180. If I go 210 degrees, I land here with a 30-degree reference angle. Okay, because from 180 to 210, there's a 30-degree difference. And from there, I know the sides of this triangle are 1, 2, square root of 3. And I just have to pay attention going left, going up, negative, positive. And my final answer is just the ratio opposite over hypotenuse. So opposite over hypotenuse is 1/2. You can check that one just the same as all the other ones. Sine of negative 210 to get that 1/2. Okay, but you have to draw a triangle out for me for those ones. So look out for that. Now that's also going to be the case sometimes when you see 5. Okay, so there are some nice triangles we know that end in 5. Okay, 45 degrees itself. Over here, 135 degrees. Down here, 225 degrees. Here, 315 degrees, and so on. We could go clockwise those values. We could go around a lap and a little bit more. So look out for those ones when you can draw a triangle to save yourself some time. Okay, so this is an example we just talked about. A cosine of 135 degrees is a nice triangle. So let's draw it out. 135 degrees gets us here with a 45-degree angle in the corner. We've got 1 square root of 2. You just have to watch out for signs. Going left, going up. So we've got a negative square root of 2 over 2 for that one. Okay, and that decimal is negative 0.707-ish. So if you're wanting to compare, that's what you're looking for. Last one, same thing. It ends in a 0. So when it ends in a 0, we got to watch out for that. Just triangle drawing here. We've got a 30-degree reference angle again. 1, 2, square root of 3, and signs. We're going left and up, so negative, positive. Then opposite over hypotenuse for this one is a nice 1/2. Okay, so what I want you to do is problems 9 through 11, deciding whether you need to use a sum or difference formula, or if you can just draw out a triangle. After you complete those problems, come back to the video and we'll check them. All right, here are your answers for those ones. Again, you can just check these in your calculator. If the numbers don't match up, most likely it's a sign error. There weren't any issues on number 9 with signs, so if you messed up, it was by choosing the wrong formula. On here, you did have a quadrant 2 value, so if you messed up, that answer is, again, because we have a negative cosine in quadrant 2. Last one, same concept. Watch out for your double negatives for your final answer looking like that. Last thing we're going to do is talk about how these problems can apply to proofs as well. So we're going to see proofs for these ones look a little bit different than the proofs that we saw before, because you're going to see values substituted in for angles rather than just seeing theta and x. We're going to actually have numbers in here. We're still going to expand out because that's going to help us simplify. Okay, so let's take a look at this first one. We've got two angles, alpha and beta, and we're looking for a difference with cosine. So it's this formula down here. So we're going to make a substitution, and what's going to be important for these ones is that you actually put times in, you label your degrees, things like that, since it is a proof. So cosine of 270 degrees, and we're putting times in between so we don't lose that. And then cosine of the second angle is literally just theta. Okay, then we're putting plus sine of the first angle, 270 degrees, and then times sine of the second angle, theta. Okay, and so that tells me that's how much room I need. From there, we can substitute in just like before, but with 270, it's a nice value on our unit circle, 0, -1. So the cosine of 270 is 0. So we're subbing in 0. And then on this side, we're subbing in -1. I know that plus and negative is minus, but this is a proof, so I'm not skipping any steps. Everything comes down, so we can see that direct substitution. So here, 0 times anything is 0. Plus a negative is -1 sine, or just minus sine. And 0 minus sine is negative sine to finish up. And that's it. The same thing is going to be applied on the next one. We're looking at sine, and we are looking at a sum. So this is our formula. Again, label these to help you, alpha and beta. And we're just subbing in. So sine of the first angle, theta, times cosine of the second angle, pi over 2. We don't need a label on that since it's radians. Then plus cosine of that first angle, theta, times sine of the pi over 2. how much room I need, move it over, and substitute in. So pi over 2 is up here, another nice value, 0, 1, and we can substitute. Sine theta times the cosine there is 0, plus cosine theta times the sine there is 1. Then I do some simplifying. Sine times 0 is 0. This is regular cosine. And 0 plus cosine is cosine. Again, if you have a sign error as you go through here, check your formula or check the value on your drawing. Okay, but that's everything that's new. If you have any questions on your homework, of course, please come ask.